Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Mechatronics brings it all together. Our guest speaker today is Mr. Dave Ranson, Managing Director at MOOC India Technology Center. Mr. Dave Ranson began his aerospace industry career in 1981 with MOOC Inc. In the ensuing 30-plus years, he has been responsible for developing leading-edge technology for several major aircraft programs. 15 of those years, he has worked as a senior manager leading the design, development, and qualification of flight-critical aircraft components with responsibilities spanning the US, UK, Brazil, and India. Dave is a professional mechanical engineer registered in the state of California. His education includes a Bachelor of Science degree in Mechanical Engineering from the University of Southern California, an MS in Mechanical Engineering from the State University of New York at Buffalo, and a Presidential MBA degree from Pepperdine University. As Managing Director of the MOOC India Technology Center, Dave has guided the development of critical engineering competencies and a qualification test laboratory, as well as achieving AS9100 certification. Current projects include embedded flight control software and electronics, flight control actuation components, and qualification testing for the Boeing 787 and Airbus A350. MOOC's India Technology Center is now a center for innovation for key technologies that support aerospace, automotive, and industrial controls. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Ranson.
Good afternoon. I've been looking forward to our talk this afternoon and hearing from you afterwards. I want to make this time valuable for you. So while we give you a brief look at aerospace as an industry and as a possible career, I'd like to encourage you to think of questions that you might ask at the end. Today we're going to focus on mechanical engineering and mechatronics. Can you all see the screen now?
No, we still cannot see your screen. Okay, now we can see the screen.
Finally, let's see what happened there. Sorry about that, folks. Okay, so there we go. So let's start over. Today, we look at aerospace as an industry and as a possible career. So I'd like to have you think of questions you might ask at the end. We'll be talking about mechanical engineering and mechatronics, and I should also say that aeronautical engineering is very closely aligned with mechanical, and they both require many of the same classes. So we'll be looking at aeronautical engineering also as a key part of our discussion. So let me ask you, why did you choose engineering? I'd like you to think about that question as we're talking today. We'll come back to it. Because as you're thinking of a career in aerospace, the answer to the question about why you chose engineering is important too. I started my career in aerospace in '81, and I had the privilege of working at 4 fine aerospace companies in the last 30 years. If I just briefly explain, I work with Moog. It's a worldwide designer and manufacturer of precision motion controls. We have offices in 28 countries and employ about 11,000 people. Annual revenue last year was $2.3 billion US, and we'll probably close this year at around 2.45. Mechanical engineering and mechatronics bring together key engineering disciplines to develop complex systems and meet the extreme demands of aerospace. For aerospace systems, the drive is always for faster, lighter, stronger, and less costly. And then in extremely cold and extremely hot environments. It's never an easy job. It requires engineers from almost every domain. On this slide, you can see we've represented mechanical, electrical, and computer engineering, as well as control theory, all required to optimize systems for aerospace. All of these disciplines have to work together toward a common goal using a systems engineering approach, which pulls together all of the appropriate engineering disciplines and provides a structured approach to solving complex problems. Today, we're focused on mechanical engineering, shown by the red oval, and its cousin, mechatronics, shown by the larger blue oval. Mechatronics pulls together electrical, computer, mechanical engineering with control theory. We can think of mechatronics as the pure engineering component of systems engineering. So have you thought about the question I asked you earlier? Why did you choose engineering instead of another profession? Your answer to that question will help with the next question, why choose aerospace? Keeping in mind that aerospace is not for everyone. I'll tell you why I've chosen aerospace as my career. First of all, I love the fact that we design, build, and test things that fly. There's nothing better than that. Second, in aerospace, we use the latest technology, and we get to design things that actually go to Mars. They go anywhere. On the other hand, getting into aerospace is not easy. It takes hard work. You have to be good with math and science. So the hiring is very selective. But even though it's hard work, it is worth it. We get to work with the latest technologies. In some cases, we're asked to invent new technology. And once in a while, we get to be part of making history, including the landmark accomplishments like the LCA. And Mo participated in India's light combat aircraft. But there's another side of the business that we must never forget. Millions of people fly on aircraft every day, and they've come to expect that the aircraft will make it to its destination without any problems. Let's talk briefly about a serious side of the business, safety. This has been a familiar sight for quite a few years. The NASA Space Shuttle lifting off for another mission. This photo is of Space Shuttle Mission 51, the Challenger. No one knew that this flight would end in disaster, but it was in fact an inevitable surprise with terrible consequences, and it could have been easily prevented. O-ring damage on Space Shuttle Flight 2, STS-2, should have grounded the entire fleet because it was classified as a criticality 1 failure. However, because of budget and schedule pressure, the shuttle program decided to conduct risk reduction testing on these damaged O-rings and to test them at 3 times the normal pressure to see if there would be a failure. Based on those successful tests, they made the decision to keep flying, which was clearly against their operational guidelines for the program. In the ensuing missions, there were 12 instances of O-ring burns, and each time the decision was the same: keep flying, and it reinforced the previous compromises. The damaged O-ring eventually led to failure of the wall on the solid rocket booster. You can note the bright spot near the lower end of the solid rocket booster run. Ultimately, this led to the solid rocket booster tearing away from the shuttle and the main fuel tank, resulting in the destruction of the shuttle and the loss of 7 crew members' lives. After the failure, you can see here the 2 boosters continued to fly while the shuttle wreckage plummeted to Earth. Engineers in aerospace are sometimes called upon to make difficult decisions, and it's very important that anyone considering an aerospace career should prepare to make difficult decisions. The poor decisions that were made early on in the shuttle program came because of pressure to meet the schedule and the budget, and the team ignored their own operating guidelines. Since they didn't see any failures, each time the decision to ignore the danger signs became easier and easier, in spite of several memos from concerned engineers. Ultimately, the inevitable failure occurred, and the results were tragic. The lives of hundreds of people were forever changed. Friends and family of crew members will never be the same as a result of that fateful day. One more thing. Before we move on, I want to make it very clear that I have the utmost respect for the thousands of engineers who work on the Space Shuttle program, all of them with the highest principles and integrity. Please don't let the mistakes of a few engineers color your opinion of the fine men and women who made the Space Shuttle program a reality. Clearly, this is serious business. In aerospace, lives are at stake. So as you're considering an aerospace career, you need to understand how important it is, how critical it is that we get it right in aerospace, because the decisions we make are so important. 90% right is not good enough, because our products have to be as safe as possible. That's why engineers are so important to this business. So let's talk about what you might do as a mechanical engineer or in mechatronics for aerospace. Most projects in aerospace can be divided into 7 major phases for a new product. We'll just talk about those briefly here. Keep in mind that although the domains are very different, no one discipline is more important than the other. There must be a cooperative, collaborative environment and a spirit of teamwork working between all these disciplines. The first discipline, system requirements and architecture, is the way you get started right. And as you all know, if you don't get started right, it's difficult to finish right. This domain is often the domain of mechatronics engineers because it requires bringing multiple domains together in an optimum manner. Product design and analysis can be both mechanical or mechatronics engineers. And this is the traditional engineering design that many of us think of when we think of engineering in aerospace, where the products are from the specifications, design, and drawings and analysis. However, product development and integration is a vibrant, exciting part of this business, and in fact where mechatronics engineers have so much impact, because this is the domain where we take the theoretical design and we turn it into real hardware and real systems for aerospace. After that, testing and certification assumes a major role, because understanding that the product will meet performance requirements is one piece. But the other piece that's so important is understanding where the weaknesses of the product are and making sure that they are compensated for or corrected so that there are not failures in service. Other domains that are not as well known but just as critical include reliability, maintainability, and safety, where mechanical engineers are very active, and this is a very important part of the aerospace business. It requires some significant engineering capability, both practical hardware knowledge and theoretical. Manufacturing, supply chain, logistics are all places where mechanical engineers find real satisfaction, and make a real impact. And then lastly, but actually active during the entire cycle, is project management. Being able to organize the program ahead of time and then keep the program in control. So those are just a few of the areas where a mechanical engineer or someone with mechatronics experience would work in aerospace. For any of these domains, you can enjoy great career success and satisfaction, and you can make a good living. And the thing that's great about aerospace is you don't have to become a senior manager to do that. In some companies, such as Moog, the technical career path is valued just as highly as the managerial path. At Moog, the designation principal engineer is respected and compensated as highly as engineering section head. The message is, you can be very successful as a techie. The reason that works, especially at Moog, is because of our values. It's not about titles or position. It's about the job you do. Moog's value is competence is king, meaning that fresh engineering graduate or experienced engineering manager all gain respect for being good at what they do. And in general, that's the way many aerospace companies function. The other side of that is a very important distinction in aerospace. In order to have a strong technical path, it requires deep knowledge of the products, and it requires sound engineering judgment. And both of those come only with experience. Aerospace products are some of the most sophisticated, complex products in the world, and the design process, development, and certification usually takes at least 3 to 5 years. So as an engineer, it can take years to gain the deep product knowledge that's needed to advance to senior levels. So career paths for true aerospace companies look much different than in engineering services companies, and that's good for you. In engineering services companies, they often provide rapid advancement to an impressive title and sometimes a better early career salary compared to aerospace. But you should be aware that after a few years, opportunities to advance in some engineering services companies may be limited because so many people compete for the top spots. The message here is you need to decide what's important to you and then decide if aerospace is for you. Aerospace careers are more slow and steady. You can see solid, steady growth in salary, but you get the benefit, the freedom to learn and grow deep in your domain. In an aerospace company like Moog, you have unique opportunities that you don't see in services companies. Number one, you get to build long-term relationships with global experts. And the aerospace community is a small community, so younger engineers get to deal with some of the most experienced, most renowned experts in the world. And the other part is that you get a chance to build a reputation for yourself in the international community. You get to build your personal brand on an international scale, where that's rarely the case in a services company. The key word in aerospace, as you can see, I'm suggesting, is patience. So, what do we look for in a candidate? Aerospace companies look for, number one, someone who's eager to learn and ready to make learning a priority from day one. We look for someone that wants assignments to provide learning and growth. Someone who wants a coach, someone who wants to learn and be mentored. The first years of your career can shape the learning curve for not just your career, but your life. Next thing is self-motivated. We're looking for candidates who don't just wait to be told what to do next, and the cousin of that would be initiative. One way you can demonstrate that as you're considering an aerospace career is to volunteer for activities that allow you to display both your skills for people skills, the soft skills, and the hard skills, the engineering skills. Look for opportunities to volunteer, display that. And then passion. It's hard to quantify, but it's very important. We're looking for engineers who are enthusiastic about engineering and are committed to work hard in pursuit of a goal. Leadership. We're looking for a demonstrated ability to plan and organize and to get a group energized to action. You could show that by organizing an event for a large group of people, even if it's a company party, because it requires negotiation and motivation and flexibility. We value these qualities. Many organizations value those qualities. We're looking for someone who can inspire others. It could be as simple as convincing a group of your colleagues to undertake some activity, or maybe just to inspire them to set higher goals. Probably the most neglected skill is communication, and yet it is so important. If you can develop a professional writing style, you will go far. And it's something that you continue to develop during your entire career. Of course, verbal communication is critical. And you need to be able to speak well in a room with a small group. You also need to be able to speak well on the phone, because this is a global business now, and you have to be able to communicate with colleagues on the other side of the world. Speaking of leadership, healthy organizations recognize that leadership development is crucial to their current success as a company and even their survival. At Moog, and I think in other aerospace companies, in order to be considered for a leadership position, there's some specific things you have to demonstrate. Most importantly, though, I should point out, you need technical competence in your domain. As a mechanical engineer, you better know mechanical engineering principles. You better know the product. Because in aerospace, without that, you won't be considered for a senior leadership position. There is such pressure to make good, solid decisions with sound judgment that require product knowledge as a leader. Moog and others believe technical competence is the first requirement for leadership. After that, I've listed 3 others here that I think key that you can work on even today. Initiative and ownership. We're looking for men and women who want to take action. They're willing to take initiative to make a decision to move without being told. And as part of the team, they're willing to take ownership with the team for getting the goal accomplished. Even if it's not quite their job, they take ownership along with the team to help get the job done. The next one, getting things done through others, is actually a composite of being able to plan and organize and delegate well, which is certainly a leadership capability. But it's just as critical to be able to communicate and encourage others to get the job done, because sometimes the job is difficult. Many times, obstacles arise, and a leader is someone who can help the team see a way to continue and to succeed. The third one, building relationships at all levels, is another very important one. As an aerospace engineer with either mechanical or mechatronics background, you will find that as you continue to excel in your engineering, that you'll have more and more opportunities to build relationships with peers, with seniors who are guiding your work, and even executives, because you will be an important part of getting the job done, and your opinion will be valued. So your ability to build relationships with peers, with those who are senior to you, and also with those eventually could report to you is critical. So what should you do to prepare for an aerospace career? My advice is simple. Learn one thing well. Master the foundations of mechanical engineering. Because if you understand the why, the physics, and you have solid math skills, you'll do very well. I can't emphasize that enough. Learn one thing well. What does that mean? What does that look like for mechanical engineering and mechatronics? I'll suggest these key subjects as you're preparing. Strength of materials and machine design are critical. Material science, understanding the fundamentals of materials. Fluid mechanics, understanding computational fluid dynamics and that whole set of analysis is optional. It's a very powerful tool, but not required as what we would call the basics. Knowing engineering tools, some kind of a CAD tool or a finite element analysis tool would be great. It's not as important which tool it is, although NX and CATIA are what many aerospace companies are using these days. And ANSYS and Cosmos and several other programs and Ostran for the finite element analysis. The exact tool is not as important as your understanding of how to apply a tool to a real engineering problem. We're not looking for computer experts. We're looking for engineers who understand the fundamentals. And as you use these tools to reinforce your understanding of the fundamentals, you'll do well. The last one, manufacturing technology, is in the curriculum, but not often valued by students as I've seen so far. But I need to emphasize that for your success as a mechanical engineer working in mechatronics, your long-term success will be gauged in part by how much you understand manufacturing technology. We look for an understanding of how parts are manufactured, assembled, and tested. Because without that, it's so easy for an engineer to propose solutions that are impractical because they're difficult to assemble or test, or too costly because of choosing a manufacturing method or a specialty material that costs too much. And quite frankly, the best way to gain that understanding is not in a classroom. The best way to get that understanding is to get your hands dirty. That's the best kept secret, I would suppose. We'd like you to take training in manufacturing technology. Learn about how things are made. Work with the shop and the lab to understand the challenges they face. And let me emphasize this. The lab and the shop are our partners. And their work is every bit as valuable as the engineer who's making a calculation or designing in a CAD scope. We expect that the engineer will be willing to get his hands dirty and learn from his colleagues in the shop and all that. Probably the best kept secret in academia. But the most important thing is that you stay curious. We're looking for more than academics. Certainly, we expect that you'll be good at your exams, but we really are looking for problem solvers, not test takers. The problems that must be solved in aerospace require a fresh perspective, not the textbook answer. So the most important thing for your career is to stay curious. The most successful mechanical engineers in aerospace are those who want to understand the why of the question, not just the how. So to wrap things up, mechanical and mechatronics engineers for aerospace see challenge and they enjoy an exciting career. But it's also very serious business because lives are at stake. As you prepare for a mechanical engineering or mechatronics career in aerospace, I would advise you to learn one thing well. Master the foundations of your discipline. You can learn the rest on your job. We want to help you learn the rest. You just need to come with a strong understanding of the fundamentals and the desire to learn. So stay curious. Never stop learning. Never stop wondering why. Thanks. So let's see if you have any questions. You can follow me on Twitter, or you can check my website. I'll leave that up. But we'll look at some questions.
Well, thanks for the insightful presentation, Mr. Radson. I would request our attendees to please send in their questions if they have. We have a question from Ms. Malvika Bhatt. Mr. Ranson, can you please answer that?
I'm not seeing any questions. Bear with me, the question stream has disappeared. I would need to see if I can. Yeah. There we go. Okay. Does a mechanical engineering student have any part in aviation? Absolutely. There are opportunities for students to take internships. I would encourage you to look into that. But one of the most important things is to make sure you get an exposure to working in the lab at school. You work on a project that takes you into the lab for a practical application more than just theoretical. Next question I see is, why is my emphasis on mechatronics only? Yeah, I didn't mean to emphasize only mechatronics, but let me say this, that mechanical engineering is the foundation for most of those activities. And mechatronics then pulls in electronics and computer engineering some control theory to help with the integration piece. And so I'm a mechanic, for instance. I'm a mechanical engineer. And most of my career, I've worked in the mechatronics domain, although I did not, per se, get a degree in mechatronics. And so where I was saying mechatronics, please feel free to substitute the word mechanical engineering. Yeah, both. But there's no reason you have to feel like you're limited. Let's see. Next one is, I'm in final year of engineering, mechanical. Let's see, what should we do to make an aerospace career? So I would encourage you, make sure you have the basics that we talked about, mechanical design, strength of materials, material science, and then look for classes that will help you understand control systems or systems engineering approach, how things work together. So if you've had some electronics engineering course as your curriculum, that'll help you look for perhaps a project that can do a little both. There's another question here. Is Mode providing any internship opportunities? We do have some limited internship opportunities, and you could contact our HR about that. What are the prospects for mechatronics? That's a question from Adarsh Kumar. Prospects for mechatronics are very good. Mechatronics only started about 40 years ago, compared to mechanical engineering, which has been recognized as an engineering profession for a couple hundred years. More and more, we're finding that software, electronics, and mechanical design all come together in products. If you look at the iPhone in particular, that has a great deal of mechatronics involved there. If you look at things, maybe even a better example would be your automobile. The automobile has turned from a very simple mechanical engineering invention 100 years ago to now being a very sophisticated computer-controlled electronic, if you would, mechatronic vehicle. So great prospects for mechatronics in aerospace and in other domains, especially in India. Are there other questions? Well, I'm enjoying the conversation. I hope that you're enjoying it. I've enjoyed my career so far, and I'm looking forward to more. And I'd love to continue the conversation with you about your interest in mechanical engineering or mechatronics in aerospace. Feel free to follow me on Twitter or my website. I'm happy to connect with you there.
Well, thanks, Mr. Ranson, for your session on Mechatronics Brings It All Together. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgeek.com by tomorrow. Thank you all. Have a great day.
And thank you for your moderation. Thank you very much. Have a good day, everyone.